Greetings. This is the Unit 6 Math Assessment Review. You should put your name and number at the top of this. This is several pages. It's a lot of work, and I would recommend the following. Please go through the questions and see if you can do them. Even if you can just feel like you're coming close to the correct answer or using a strategy that you think works, try it. Go through all the questions. See what you can do. Put a star next to anything that maybe you are very unsure about. Maybe you see a question, you're like, no clue. Or maybe your star is an indicator that you think you're close, but you want to review it. Then when you're done, use this video and fast forward to the questions that you need. Otherwise, this is going to be a pretty long video. You're more than welcome to watch all of it, of course, but that's just my recommendation. So let's dig in. I have a rectangle, and then something that's a little bit more square, and then I have something that's a lot skinnier and longer. This is interesting. 10 times 24 equals, it doesn't look like they want the answer to this, do they? Because here's my 10 and my 24. I have a 20, and this arrow indicates that this rectangle is changing in different ways. So let's take a look. 10 and 44, 10 and 20. 10 and 44, I'm probably going to need to change these two numbers, okay? So if I put in this 20 here, it looks like we edited a number. I'm guessing because 20 and 10 have very close relationships that I should figure out how 10 becomes 20. Well, it looks like you double it. If you take 10 and you take it times 2, you get 20. What is the rule that we've talked about earlier in this unit? We talked about doubling, and we talked about halving. So we've talked about if you double one number, you need to cut the other in half. Think about that. We doubled the 10, so the 44 needs to be cut in half, okay? And if you're cutting in half, what does that mean? You're dividing it by 2. What is half of 44? 22. So just to make sure we're on the same page, if you're going to take two numbers and you're going to change one of them by doubling it, the other number needs to be cut in half, so that you end up with the same answer. Because even though this question doesn't ask for the answers, we know that 10 times 44 is 440, which I guess I could write in here. But we also know the same is true here, because of this rule that we've put in our handbook, okay? Now, what did they do to the number over here? Well, if we're looking at this top number, 44, I cut it in half, 22, and we see that this rectangle gets a little bit shorter, right? So this side that's 44 here, when I cut it in half, is now shorter, and it looks like it's even shorter here. Did they double it, or did they cut it in half? Well, if it's shorter, I'm going to say they cut it in half, which is dividing by 2. And then if I look at the short side over here that I'm coloring blue, they doubled it, made it twice as long, and then look, they made it even longer, which means that we are cutting one in half, our top ones, maybe the ones that I colored red, and we're doubling the blue ones. So 10, if you double it, becomes 20. 20, if you double it, becomes what? Well, I'm hoping you're going to say 40, because 20 plus 20 is 40, and I'll put that here in the box. Keep your thought process going. 44, you cut it in half, that becomes 22. Cut 22 in half, what are you left with? I'm hoping that if you paused this video and you thought about it, then you came up with 11. But regardless, the answer to my problem is still 440 if I multiply them. Keep in mind, they are not asking you to solve the problem, are they? They just want to know what should the rectangles be, okay? Let's move on. speaking of doubling and halving and maybe skip counting, right? Some of those kinds of ideas. These are true or false. If I look at these two numbers, 39 times 15, what does that say? That says I'm going to count 15 39 times. Here's my equal sign, which means that we're trying to figure out if we can get the same answer with these two multiplication problems they have here. So once again, how many times are you going to count 15? 39 times. That's this side of the equation. Now, if we look at this side, it looks like they're going to count 15 40 times. That's one more than that, right? But they're also going to get rid of one of them. So if I have 15 times 40, but I'm going to get rid of 15 times 1, if I get rid of one of them, that 40 becomes what? Becomes 39 again. So that is 39 times 15, just written in a different way. So I'm going to say that that is true, and you should write the whole word out just so nobody confuses your handwriting, okay? Now, are they trying to trick you over here? 48 times 18 is the same as 24 times 36. Are there any number relationships I could look at? Maybe I could get my highlighter out to help. If I look at 48 and I compare that to 24, isn't 24 half of 48? Or you could say 48 is the 2 times as much as 24. So it kind of looks like, once again, that maybe we're going to talk about this. Oops, and I did the wrong one. Kind of looks like we're going to talk about this doubling and halving again. I'm just going to keep writing this because it's really handy to be able to see it while you're working with it. So what should happen? If I took 48 and I cut it in half, what should I do with my other number? I should do the opposite, right? I should double it. Is that what happened? Let's find my arrow here. 48 divided by 2, 18 times 2. They did opposites, so that is true. The one thing that you're going to have to be very careful with is if they wrote a problem where they only do one of the operations. Can I write an example? Let's say they took that 48 times 18 and they wrote, what would that be, 96 times 36. You might be tempted to say that is correct because they doubled. And you're like, oh, good, they did the same thing to each one. Oh, no, they have to do opposites. If you double one number, you have to cut the other number in half, okay? Let's continue. 72 times 68. 70 times 60. 2 times 8. Oh, gosh, you might say to yourself, well, looks like they took the 2 away from 72, because 70 plus 2 is 72. But 68, they broke it into 60 and 8. So wouldn't that be correct? Well, I think we should work it out to see the difference, okay? So I'm actually going to calculate this. Okay, I'm going to take 72. Oops, and that's the wrong pen again. 72 times 68. And for my people who love the standard algorithm, here we go. 8 times 2 is 16, carry the 1. 8 times 7 is 56, plus 1 is 57. Always start the next line with a 0. 6 times 2 is 12, carry the 1 again. 6 times 7 is 42, plus 1 is 43. If I add it all down, I have 6, I've got a 9, I have an 8, and a 4. Pretty big number. Now what I'm going to do is, now that I have this side solved, I'm going to solve both of these, and we'll add them together. Some of it is mental math, right? 2 times 8 is 16, so I know the answer there. And then I'm going to use kind of my zeros rule here, right? 7 times 6 is 42, and then I'm going to add both of the zeros on. So I have 4,200 plus 16. Well, that answer, which I'm going to pencil over here just so it's in a better spot, is 4,216. Whoa. These are not the same. Now, I did the long way to show you how that works. But what I would like to point out simply is that you can break apart one of the numbers you can break 72 into 70 and 2, that's fine. The other number has to stay the same or your math does not work out. What is an alternative that they could have written that would have been okay? I'm going to write it down here in maybe green. So if they would have said 72 times 68 is the same as, well, let's break the 72 into 70 times 68 plus 2 times 68. And if you can see here, the difference is I broke the 70 apart, that's fine. But I kept the 68 the same. You cannot break them apart or else the math does not multiply and add up correctly. Tuck that away. Keep that little nugget of wisdom in your brainium, okay? So that is false. I'm going to spell the whole word. Finally, and I know this question has taken a while, but if this is one of the questions that you were unsure of, then hopefully you are giving this your best attention. 97 divided by 8 is the answer 10 remainder 2. Could we check this answer just by using the answer they gave us? The answer is yes, because I should be able to take this times this, add the 2, and I would have the correct answer. So let's do that. I'm going to write it in, we'll do blue. So if I take 10 times 8, those are my two numbers here, the 10 and the 8, I get 80. If I then add this remainder 2, I get 82. Oh man, that is not the same answer that's right here. That says 97. If you were the kind of person that just wanted to find the answer that it should be, you could also do that. And I know I'm kind of running out of room here, but I'm going to do this over here. 97 divided by 8. And there's a couple ways you could do it. But once again, I say, how many 8s fit into 97? And if you're like a little bit on the side that doesn't have your high math facts figured out, well, couldn't you at least start a ratio table where you're very comfy? You know, we've got 1 over here and 8 over here. Well, I know that 10 times 8 is 80. Well, maybe I just count up by 8s until I get the right answer. Well, 8 times 11 is 88. I'm getting a little bit closer. And then if I do 12, so then I add 8 to that, I'd have 96. And that's as close as I can get. So we know that it's a 12, okay? So how many 8s fit into 97? Well, the answer is 12. That gets us 96. How close is that to 97? Well, that's 1 away, so that's my remainder. Okay, 12 remain. Oh, why did I write it that way? So that'd be 12 with 1 remaining. Okay, so that should have been my answer. Two different ways we could have solved that problem. Okay, we have some fill in the blanks here. It looks like they're trying to use the area model to find the area of a rectangle by breaking it up into friendly numbers. Okay, how do I know that? Because I have areas written in the middle and I have dimensions written on the side. Okay, so we are going to ask ourselves this question. What times 5 is 40? That would be step 1. Okay, what, that's a question mark by the way, times 5 equals 40. That's a math fact, right? Because we know that 8 times 5 is 40. Well, now that we have solved that, we can then solve this box here. And then it's the same question. 8 times what is 400? Ooh, that might be a little bit harder. 8 times what is 400? Well, wait a second. That said 40. That says 400. Ooh, I could probably figure this out a little bit because I know, and I'll do this in a different color, I know that 8 times 5 is 40. So I just need to add a 0 to get the answer. Okay? So I know that that's a 50. Okay? I'm going to come back to that in a second to give you an alternative solution or an alternative way to solve. But for now, let us finish this equation down at the bottom, because this is now asking us, where's my arrow? This equation says what times what equals what. And if you're on the test and you're unsure of what that's asking, we now know how wide it is, which is 8. And I'd also like to know how long it is. So that would be the entire thing. So that's 50 plus 5. That is the length of the entire thing, which is 55. And then how am I going to know that area? Do I need to do standard algorithm to do 8 times 55? No, because I know that 8 times 55 is the same as 8 times 50, plus 8 times 5. My areas are already right here. So I need to add 440, and I get 440. And if you thought to yourself, wow, how did he know that that's what he was looking for? Because, do you remember how to make the numbers easier to solve? If I'm looking at 8 times 55, well, I can break 55 into 50 and 5. So then I have 8 times 50 and 8 times 5. Isn't that true? It is. But wait, whoa. That's what we have right here. There's my 8 times 50. There's my 8 times 5. So if we just combine these two numbers, we do not have to go through all the work of saying, what is 55 times 8? You do get the same answer because you have a 40, carry the 4. A 40 plus 4 is 44. You still get the same answer, but you don't have to because you already solved it right here. You just have to combine it, okay? Once again, I know some of these questions are a little bit long. However, if you need help with it, you take a look. Okay, let's keep going. All right, here I go with the same part. Now that I've spent quite a bit of time explaining it, what I would like to do is just dig into solving it a little bit faster. Okay, so I see that I have an area number here that's missing and an area number here that's missing. However, it gave us the width, which is of the whole thing, and it gave us the first length and the second length. So I'm going to try to multiply these two, and then I'll multiply these two. Okay, so if I take 22 times 10, I get 220. And then if I'm looking at this number and I take 22 times 7, you can do that in your head if you want, or if you would rather do it, you could stack it and multiply. And I'll just do it here to confirm. 7 times 2 is 14, carry the 1. 7 times 2 is 14 again, plus my 1 is 15. So my answer here is 154. Now, once again, when you see this blank equation at the bottom, it is the equation for the entire rectangle. That's why we did all that work, is so that we could have one equation for everything. So, what is area? Length times width. Okay, what is the length? Well, hopefully you're going to say, well, it's this, which is 10 plus 7. So I should have a 17. What is the width? Well, the width hasn't changed. It's still 22. How am I going to answer what is 17 times 22? Don't do the work. Here's the area of the first equation and the second. If I combine them, I will have this answer. Okay, 220 plus 154. Here's my 4. Here's my 7. Here's my 3. The answer is 374. That is my combined area for the whole rectangle. There's a lot going on there. Take your time. Oh, a nice ratio table. I'm trying to get to 39. Okay, trying to take 39 times 16. They've set us up for success here. How do I know that? Well, if 1 times 16 is 16, then 10 times that would be 16 with a 0 added onto it. Okay. Is it going to be a lot harder to do 20 and then 30? For me, not so much, because I see this pattern here. I can just take 2 times 16 and add a 0. take 3 times 16 and then add the 0. So I'm going to just ignore that 0 until I've answered the easier problem. So what is 16 times 2? Well, that'd be 32. But then don't forget, we have to put that 0 back on, 320. And then when I'm doing this one here, times 30, okay, I'm going to take 16 times 3. And of course, if you want to, you could just take your previous number, 32, and add 16, okay? And then we'd get our 48. So I have 16 times 3 is 48, but don't forget I have to put the 0 back on the end. And now here's where you have some work to do, because 39 would be counting 16 9 more times, right? How am I going to do that? Am I going to take 16 times 9 and then add that answer to 48, 480? I could, and if that's the strategy you want to use, you could go for it. What if I just figured out what 40 was and then subtract a 16 from it? Could we do that instead? I'm going to try it, okay? So I know that 16 times 3 is 48. So what if I just take my 48 and I add another 16 to it? Okay, so 14, carry the 1, 4 plus 1 is 5, plus 1 is 6, I'm at 64, okay? Add my 0 on, right? Because I know that 16 times 4 is 64, but I'm taking it times 40, so make sure you put that 0 back on. If I want to go back, okay, so I have 16 times 40. If I want to do 16 times 39, I need to get rid of one of the 16s, okay? So I'm going to take my 640, and I'll try maybe a different color. I've got a lot of red going on here. Subtract 16, and I will be in the exact right spot. Let's go and borrow from this 4. So now I have 10 over here. 10 minus 6 is 4. 3 minus 1 is 2. 6 minus nothing is 6. So I know that 624 is what you get when you multiply 16 times 39. And you can place that in the box. Oops, it would be helpful if I wrote what I said I was going to write. Okay, ratio tables. They can be so helpful. Now, I absolutely understand that sometimes you're going to be in a bind and you're going to have your ratio table set up where you've got your 1 and your 16. I'm going to do this. And then you filled everything out and you figured out that, well, 30 is 480. And maybe you're not comfortable doing this process here where I find a bigger number and then I subtract from it. You could, in a pickle, you could do, well, what's 31? I just need to add 16. Well, what would 16 times 32 be? Well, I'm going to just add another 16. What would 33 be? I'm going to add another 16. And you could do that over and over until you finally get ... to 39, okay? That is a possibility. It would not be a bad one if that was your only option that you felt comfortable doing. It just requires you to be very accurate when you're adding 16 down the list, okay? Just throwing that out there. I want you to be aware. Okay, and that is that page. Yay, let's keep going. Fill in the blanks to make each equation true. Oh, goodness gracious. I've got to readjust my chair so I can be prepared for this because it's so important. Okay, here we go. Looking for relationships. 26 times 14. What do I do? I see a 7 here. How do these numbers relate to each other? And maybe it would be helpful if I gave them just a little bit of a highlight here. That's the second number of the equation. That's the second number of the equation. I do think that's important to remember because they're not going to flip-flop it and try to confuse you visually. So like 26 is the first number. They left the first number blank. They're going to be related to each other too. So I've color-coded them. The reds are the first numbers. The blues are the second numbers. See what the relationship between 14 and 7 is. Well, it looks like they cut 14 in half. Uh-oh, spaghetti-o. Do you remember? doubling and halving. Okay, so what did we just say? They took 14 and they cut it in half, which means this has to be the opposite. We already cut a number in half, so this number needs to be doubled. If I double 26, I'm taking it times 2. And if you want to, you could do it this way, 26 times 2, and then do your math that way. You could do it in your head, or you could just do 26. Oops, that would be helpful if I wrote the number that I said. 26 plus 26. Oh, I did it again. What's going on here? But either way, you're going to double 26, and you're going to get a 52. Okay? That either way you solve this equation, if you do it this way or this way, you're going to get the same answer because we used this rule for doubling and halving. Okay? Let's go again. My first number is a 110 on this side of the equation. My first number on this side of the equation is blank. My second number on this side of the equation is a 6. The second number on this side is a 12. What is the relationship between the two that match? 6 and 12. I took the 6 and I doubled it. Check. Done. Which means the other one has to be halved, cut in half. There's a couple ways you can do this. I'm just going to draw them just so that there's no question. I could say 110 and I could do long division and divide it by 2. I really could do that. I could do this in my head if I'm pretty good at splitting numbers. I could also break this into 110. And most of the time, if you do that, you're going to find that mentally you can cut 100 in half and get 50. You can cut 10 in half and get 5. And when you add them together, you get 55. Same answer regardless. Okay? So these equations are now true because if I multiply these two numbers, I'm going to get the same answer as if I multiply these two numbers together. Those equations are true. Now we're going to get away from the doubling and the halving for a second because we're going to talk about the number of times that we're counting these numbers. Okay? Might be helpful to highlight this, so I'm just going to just go for it. Looks like this 14 stays the same. Okay? Which means that my relationship here is going to be changing with these first numbers, okay? What happens let's say, on this side of the equation? I'm going to count 14 79 times. So I'm going to do 14 plus 14 plus 14 plus 14 plus 14 79 times, okay? Well, it looks like they want you to subtract one of the 14s on this side. What would this number have to be? So that if you subtracted one of them, you would get a 79. Well, I do believe that you would need this number to be 80. Because if you're going to count 14 80 times, and then you change your mind, you're like, just kidding, we're gonna take away one of those. We're gonna count 14 one less time. Okay? So you're like, oh, I'm gonna count 14 80 times. Just kidding, we're gonna take away one of them. You would have 79. Okay, now they match because 80 of them minus one of them is the 79 that's on this half of the equation. I do kind of want you to look at that. That equal sign is kind of a me versus them. That's your dividing line that you're looking at, trying to make sure that your equation is balanced on both sides. Okay, let's continue. I hope this is going well for you. Looking for some numbers that match. They split a number. So they took, don't like that color. I like to do blue second. Looks like they took a 27 and they split it into 20 and 7. Do you remember the rule from the previous page? I went over this specifically, and I'm hoping you remember. You are allowed to split a number, aren't you, into its different parts. 20 plus 7 is 27. You cannot do what, however? Split both of them. So if you split one of them, the other one has to stay the same, which means that the number that, I'm trying to get my red highlighter. The other number has to be the same. So 53 cannot be changed, so I am simply going to write that number in. It has to be a 53. You can only change one number. And finally, in E, we have an 86 and a 42. Looks like we didn't keep the 86 here, but we kept the 42. What does that tell us? Let me get my highlighter because I want to make sure these colors match. Looks like we're counting 42 a certain number of times, okay? On the left side of the equation, it says we're going to count 42 86 times. On the right side, we're going to count 42 80 times. How many more times do we need to count 42 to get to 86? We have 80 of them. We're trying to get to 86. Well, to me, it looks like we are going to need to count 6 more of them because 80 and 6 will give me my 86. Okay, let's keep going. Fill in the ratio table to find 192 divided by 8. To flip that equation around, what does it look like? 8 times what number is 192? And whenever I see these, I don't know how many of these I'm necessarily going to need. So I usually just draw a bunch of them till I get to the end. And then whatever I need, I use. If I need more, I add more. I don't try to sweat it too much, okay? But we're trying to put an answer right here, okay? And we're counting by 8s, trying to get to 192. And I have, if I have count 8 once, that's 8, right? 1 times 8 is 8. I like to think that in my mind when I'm considering this ratio table, whatever I have in the top row, I'm taking times 8, okay? So if I write a 1 here, I'm taking it times 8, and then I'm writing my number down here. 2 times 8, 16, so on and so forth. Is it going to be helpful to count by 8s all the way up to 192? No, not really. So in my mind, if I can't count by single 8s, 8, 16, 24, 32, if that's not going to be effective, then I just skip to a friendly number that I know. In this case, I kind of like counting maybe 10 and then 20 and then 30, that sort of thing. And then to figure that out, remember that you can use your strategy with zeros is you can kind of ignore the 0, say what's 1 times 8? Well, I know that's 8, but then don't forget to put your 0 back on. 10 times 8 is 80. Same thing for this. 20 times 8, well, just forget the 0 for a second and say 2 times 8, well, I know that's 16. Then if I put my 0 back on, it's 160. Okay, and then I keep going, 240. Uh-oh, spaghetti-o, that is too big. I've just gone over 192. So I know that 20 times 8 is 160, and that if I'm going to get to 192, I have to go more than that. So I know that I'm more than 20, but I'm less than 30. And I'm just going to draw an X on this one because I know that that's too high. There are so many ways you could do this, but if you want to be methodical, if this is something you're not comfortable doing yet, maybe you just go up by 1s now. Like maybe I do 21, and then I do 22, and then I do 23, and then I do 24, until I get to this number here, okay? So if 20 times 8 is 160, if I do 21 times 8, I'm just going to add 8 more, right? So if I do like a plus 8, right? Well, that'd be 168. And then to do 22, I'm going to add 8 more, right? And that'd be, what is that, 176. And then to do 23, I'm going to add 8 more. And that is 184. Okay, and then if I'm going to do 24, I'm going to add 8 more. And that is, oh, look, 192. I've made it. So it says, what is 192 divided by 8? Well, or if I say 8 divided by what is 192? The answer is going to be this 24 right here. Because 24 times 8, right, that's what we're saying, is 192. So my answer is 24. Okay? Let's finish this array right here. The key word is finish, okay? Because we're dividing 1,575 by 5, and they've already started us with a nice pattern, trying to say that, well, we know that 5 times 100 is 500. That's easy. We can do that in our head, right? Well, now we finish it by continuing our rectangle. And maybe I'll try to do this in black to see if I can keep my rectangle going, right? Sorry if my shapes aren't amazing. But do I have enough room to maybe do this again, 5 times 100? We can't change the 5 because that's right here. We're dividing this number by 5, okay? So our width is going to stay the same. We're going to see how long this needs to be until our area is 1,575. And the answer to that question is, can we do another 500? Yes, because if I keep track of my math down here, 1,575, and I take out this 500 that we already did, well, now I have 1,075 left. Wow, I wrote that real weird. Let me try that again. 1,075 left. Yeah, there's enough room to do another 100. And then once again, 5 times 100, well, that is 500 again. Now I have 500 and 500. So if I take another 500 out of this, then my answer is 575. So that's how much I have left. Do I have room to do another 500 from this? I absolutely do. So I could do another rectangle that's 100 long. And then I know that, once again, that 5 times 100 is 500 again. So now I have 500, 500, and 500. That's 1,500. I'm going to rewrite this number down here just so I can keep track of my math. 575, and I'm going to subtract the 500 that I just figured out, and now I have 75 left. This is something that I think we can do, either in our head or with a ratio table. But this last rectangle is not big enough to do another 5 times 100. So it's going to be a smaller rectangle. And I have to figure out, what is this number going to be? I know that this number is a 5 because I can't change that. So I'm trying to say, what can this be that gets me a 75 in the middle? Because that's what I'm missing, okay? So I say 5 times this number is 75. And if you wanted to count on your fingers or set up a ratio table, you could do that. But I think if my math is correct, is it 15? Is that right? I'm just gonna do it real quick. If you do, I kind of like doing long division. Sometimes it works, sometimes it doesn't. We got a 1, we have a 5, I subtract, I get a 2 and a 5. Yep, it's 15. So if I put a 15 here, I'm gonna write this in blue, then I know that 15 times 5 is 75. Now I have 500 plus 500 plus 500 plus 75 is this number. So if I divide this big number, right, all of these that I just added up, if I divide it by this 5 here, my answer is everything up here combined. So that's the 100 and the 100 and the 100 and the 15. And if I do combine those, well, I do know that if I have 300s, that's 300 plus 15. My answer is 315. Can I double check my answer? Yes, you can. Just by flipping it around, saying 5 times 315 is 1,575. And if you stack it and do it, I bet you money we're right. 5 times 5 is 25. Carry the 2. 5 times 1 is 5. Plus this 2 here is going to be 7. And then 5 times 3 is 15. Check it out. 1,575. 1,575. 'Tis done. Okay? This might be a question you look at a couple times if you're not comfortable. Okay? Let's keep going. All right, question 7 says, the school is collecting soda for the end of the year celebration. Oh, that's so nice. Man, they need 800 cans of soda. It's going to be a great time. So far, they have collected 30 packs of 12 sodas and 12 packs of 36 sodas. How many more cans of soda do they need to meet their goal of 800? So I'm just going to highlight a few things that are important because details matter. We need 800. Okay, that's our total. We have 30 packs of 12, 30 12 packs. Okay. And then we have 12 packs of 36 sodas. So there's a little bit of a difference here in how these are organized, right? Because I have 30 packs of 12, so I've got a dozen sodas in a pack, and I've got 30 of them. But then I also have 12 packs of 36 sodas, and so each of these packs has more in them. Well, it sounds like I have a couple multiplication problems, right? Because if I had, one 12 pack, right, I'd have 12 sodas. If I had two 12 packs, I'd have 24 sodas, right? So these are multiplication problems. So if I think about maybe the blue one first, I've got 30 times 12, okay? If I think of the second one, I've got 36 times 12. And I know that the numbers are reversed here, but it's the commutative property, right? 36 times 12 is the same as 12 times 36. I'm just arranging it this way because I like to have the numbers that match on the same side, okay? I have a suggestion. 30 times 12 seems pretty good, like a great place to start, because I know that I could just forget the 0 for a second and take 3 times 12, okay? 3 times 12 is 36. Well, then when I put that 0 back on, I have 360. So I know the answer to this is 360, okay? Now, take a look at this. I could break 36 into a couple different things, right? I could say it's the same as 30 times 12, and then 6 times 12. That would make 36. 30 and 6 is 36. And if you remember the rule that we talked about with multiplication, you can't change the other number if you break the other number apart. So if I'm going to break 36 into two different numbers, the 12 has to stay the same. Now, we already know what 30 times 12 is. We just did it right there. So I'm going to write that answer, 360. Now I'm going to look at my other answer, 6 times 12. If you know your 12 math facts, then you could do this mentally. If you're not sure, then you could do it, just pencil it over to the side. You do your 12 and your 6, multiply it out. 6 times 2 is 12, carry the 1. 6 times 1 is 6, add the 1, you get 7. We have 72, okay? Since this is a multi-step problem, you always have to think, am I done? Did I forget something? Have I answered the question that they asked me? So we did these multiplication problems because we broke this down. I really need to add these two numbers together to figure out what 36 times 12 truly is. So I'm going to do that. 0 and 2 is 2. 6 and 7 is 13. Carry the 1. 3 plus 1 is 4. So that's 432. So 36 times 12 is 432. Am I done? Well, so far we figured out how many cans of soda we have in each of those packs, the green and the blue. Does that make sense? We had 30 packs of 12, that's 360 cans. 12 packs of 36, that's 432. We need 800 cans of soda, and it says how many more cans do we need to get to our goal. So shouldn't we figure out how much we have all together? I have this many and this many. Let's see how much that is when we add them together. So I'm going to take my 360 and my 432, and I'm going to add them together. 0 plus 2 is 2. 6 plus 3 is 9. 4 plus 3 is 7. So I have 792 cans, but I need 800, okay? Kind of sounds like a subtraction problem or maybe a number line problem, right? So I'm trying to get to 800. I have 792. So I can subtract 792 from the 800 to figure out how many's left. You might be able to do this in your head, but just in case you're wondering, couldn't we real quick just do the steps so that you feel comfy cozy about it? We know that if we're borrowing, if there's more on the floor, we go next door. If we have a 0, maybe your teacher teaches you the box strategy, where if there's not enough here, then I'm going to underline until I get to what I need, draw a box around it, because I can't borrow from a 0, but I can borrow from an 80, so I draw a box around it, and then is where the magic begins. So I'm going to take 1 from that, and I'm going to have 79. That 1 that I borrowed makes this a 10. And now I can say 10 minus 2. We know that is 8. Then I can take a look at the 9 minus 9. We know that's 0. And then we know the 7 minus 7 is also a 0. So the answer is 8. Okay? Why did I think that you could do that in your head? Because if you're at 792, you're trying to get up to 800, you could count. It would take you'd have to only count up 8 to find out that 800 minus 792 is 8. So just something to think about. Some of those problems might throw you a little break. So how many more cans do we need to get to the goal? We need 8 cans. Okay? Well done. That's a long problem. I hope you did well with it. Use the data in the table to make a line plot. Finish labeling all the marks along the line before you plot the data. So they've left a whole bunch of tick marks that I don't know. So I need to fill them in. One of the things I need to think about is what are they counting by? So I'm going to zoom in just a little bit so I can be a little bit better at writing. But it looks like they're counting by eighths because I see a whole bunch of them along the way. So let's see. So there's 1 and 2/8. So that must mean that this is 1 and 1/8. And if the next one is 1 and 2/8, then I probably have 1 and 3/8, and then 1 and 4/8, 1 and 5/8, 1 and 6/8, 1 and 7/8, and then this is 2, right? Because if I add 1 and 8/8, right, that's the same as 2. Okay. Then they have 2 and 1/8, and then I would have 2 and 2/8. The next one is 2 and 3/8, and then I'm going to write 2 and 4/8, 2 and 5/8. They did 2 and 6/8. Looks like we're missing a tick mark in here. 2 and 7/8. And then, no, we're not. That's perfect because 3 is the same as 2 and 8/8, right? That's the same. Okay. Now we can start plotting our information. Take a look at this. If I look at these, it says, what is that? Kids, their jump lengths. So an X will represent each kid that we are looking at. So the first kid jumped 1 and 3/8. I'm going to place an X above 1 and 3/8. Okay, that one's done. The next one is 2.5. So I place an X above 2.5. Oh no, there is no 2.5 on this number line. Or is there? 2.5 is the same as what number? Well, it is the same as 2 and 4/8. How do I know that? Well, if I zoom way in here, I could think of it this way. To turn this number into an 8, I'm going to take it times 4. Okay? If I do that to the bottom, I also have to take the top number times 4. 4 times 2 is the 8 that we need. 4 times 1 is 4. So we know that 4/8 and 1/2 are fraction equivalents. Okay? So 2.5 is also 2 and 4/8. And I can mark that on there, and I really should, because that is true. 2 and 4/8. That student is now accounted for. And I could exit out, and that would be totally fine. So I don't accidentally do it twice. Now, the nice part is anywhere you see this 1/2, you could think 4/8. And if you want to, you could actually pencil it in. Like over here, you could say 4/8, just to remind yourself that they're the same. Okay? What about something like 1/4 right here? That's also not written in eighths, but we could figure that out with not too much difficulty. If I think to myself, well, I can make 4 become an 8 if I take it times 2, right? 2 times 4 is 8. But don't forget, I also have to do that to the top as well. 2 times 1 is 2. So 1/4 is also known as 2/8. Okay? What about a number like 3/4? It's the same issue. If I want to turn that bottom number into an 8, then I'm going to double it. So I'm going to take it times 2. And I have to take the top number times 2, or else I don't get an equivalent. 3 times 2 is 6. Okay, that number's fine. We already said that we know this one, but we can finish it. 4 times 2 is 8. And then 4 times 1 is 4. Okay? The next one's good. It says it's in eighths. That's 5/8. We're good. The next one is another 1 1/4. And remember, if we take that bottom number, if we double it, then I also need to double the top number to make it my fraction and equivalent. Moving on again, if I want to make this 4 turn into an 8, I need to take it times 2. If I do it to the bottom number, I do the same thing to the top number, double it, 6/8. The next number's fine. We already did halves, but just in case you're wondering, this 2.5, if we want to turn the bottom number into eighths, I have to take this times 4, which means I also have to take the top number times 4, which gives me a 4/8. Okay, so this entire thing is now ready to plot. And if you want to, like on your test, I highly recommend go through and turn the entire table into the fraction equivalents that you need so that you can mark them on your number line. So we've already did, let me double check. I have 2 x's so far, which means my next one is going to be this one right here. That 1 1/4 we said was 1 2/8, so I put an x. Yay! The next one is 1 6/8. I put an x. That one's done, so I have 2 done. The next one is 2 7/8. That one did not need a fraction equivalent because it was already in eighths. The next one is 2 4/8. Oh, we've already done that one, so that one gets 2 x's. This next one is 1 5/8. Find it on the number line and put an x. The next one is 1 2/8. Find that one, right? Ooh, that one gets 2 x's too. The next one is 2 6/8. That one doesn't have anything yet. The next one is 2 1/8. Right here. That one's done. And the last one is 2 4/8. Ooh, that one gets 3 x's now. That's probably worth remembering. Okay, so we have now plotted all of the lines. All of these kids, their length, the distances they jumped are now represented by these x's on our number line. We're going to need to know this information if we are going to solve the rest. Alrighty, last page, and I bet you're ready for it, but I think this is going to go well. It says, what is the difference in lengths between the shortest jump and the longest jump? Well, we know the longest data is on this side, and our smallest values are on this side. And I copied and pasted this from the previous page. So it looks like to me that the longest jump is here, 2 7/8. And the shortest jump, a couple people jumped that far, but 1 2/8. What is the difference? Right, we call that the range, right? The difference between the maximum and the minimum is the range. Difference means what? Difference means subtract. So we're going to subtract, we're going to take the largest value, subtract the smallest value, and that will be our answer. And I am going to do that up here where the paper is just a little bit cleaner so that we can see everything. So I have 2 7/8 minus 1 2/8. That is going to be our answer. Let's start with the whole numbers. If I take 2 minus 1, I get a 1. If I take 7/8 minus 2/8, well, 7 minus 2 is 5, so I have 5/8. Remember, when we are subtracting, oops, wrong one. If we're subtracting, the denominators will not change. Okay, so that answer is 1 5/8 is, and that would be, is that inches? Inches? I cannot remember. I feel bad, but don't forget to label your units, okay? So what is, just so we're on the same page, what does that tell you? What is the range? What does this 1 5/8 represent? And I'm going to put this in green. It represents the distance between the lowest and the highest value. So that is 1 5/8 inches from here to here. Okay. The next one says, how far did all the kids that jumped, how far, oh, wait, hold on, let me read this again. How far did all the kids that jumped 1 1/2 inches all together? So how far did they jump? So how many kids jumped 1 1/2? Well, do we remember which one of these numbers is 1 1/2? If you can't remember that strategy that we did on the previous page, I'm going to do it again for you. So here's 1.5, and I'm going to come on in nice and tight just for a second, just so that we can point out that our goal is to figure out how to make that bottom number an 8, okay? How do I turn a 2 into an 8? Well, I'm going to take it times 4. 4 times 2 is 8. And we cannot change the bottom number without changing the top, and it has to be the same. If I take the bottom number times 4, the denominator, I'm going to take the top number, the numerator, times 4 as well. And we know that 4 times 1 is 4. Okay? So the other way to write that number so it has eighths is 1 4/8. These two numbers are the same. They just contain fraction equivalents. Okay? And just to be super clear, I don't know if I can do this really well without making the circles look different, but if I were to take, 2 circles, I don't know if this will let me copy it exactly how I want to, but we'll see. Oh, that works really well. Very nice. If I, come on. I want to move that thing. There we go. If I take these circles and I cut them both in half, and I shade this one, or I cut this one in 4 pieces and I shade 2 of them, it is the same, right? Does that visually make sense? 1/2 right here is the same as, well, hold on. I was supposed to do eighths, so I just did 2/4. Okay, I need to cut it one more time. I'll do it with black so it shows up real good. Okay, so this 1/2 and this 4/8 is the same. So fraction equivalents are helpful because what we're trying to find out in this question is, if I took all the kids that jumped 1.5 and I add them all together, how far is that? Well, we said 1 4/8 is going to be our answer. How many kids jumped 1 4/8 inches? None of them. Easiest question of the day. All the kids that jumped that far jumped 0 inches. Okay? But what happens if maybe we, instead of 1 4/8, what if we said 2 4/8? 3 kids jumped 2 4/8. If you were going to add all of those up together, what would you get? Well, you'd have to do it 3 times. 2 4/8 plus 2 4/8 plus 2 4/8. Okay? Add up your whole numbers first. 2, 4, 6. Okay, let's put that down there, 6. And then let's add the others, which would be 4/8, 4/8, 4/8. That's going to give me 12/8. Uh-oh. I have a numerator that's bigger than the denominator. So I'm going to isolate that 12/8 and try to convert it to a mixed number real quick. Do you remember how to do that? It's a good skill to have because I believe you're going to have to do it a couple times on your unit test. And that is this. How many 8s fit in 12? Well, 1 does, because that's 8. And you can make a little note up there to remind you. How far is it from 8 to 12? 4. So we have 12/8 turns into 1 4/8. That is this number here. We have 6 12/8, but we now know, maybe I could put this in a different color, that this 12/8 is also 1 4/8. Ooh, that would be helpful if I maybe did it correctly. There we are. So if we have 6, and then we also have this 1 4/8, we can just combine them, okay? 6 plus 1 is 7, and then I just have my 4/8 left. So the answer, if I stacked the 3 x's, right, the ones here on the number line, if I stacked all 3 of them and I added them together, ooh, that's not what I wanted. Let's try this. I would end up with 7 4/8. And you could write units on that as well too. This has been a long video, but it has also been extremely thorough so that maybe there are no questions along the way. Once again, if you feel like you know it, right? Let's say that you know it. Awesome, great. You went through the video, life's good. If you went through your review and there were just a couple you didn't know and you just had a couple questions, then you just go to that part of the video. You're good. All right. And of course, if you're really struggling, maybe you want to watch all of this video and maybe watch it multiple times. But you don't have to watch all of it unless you're uncomfortable with a lot of it. Okay. And if you're in that boat, then come see your teacher. We would love to help you to try to catch you up and make you feel good about some of these concepts. Okay. Check you later.